Okay, we're still in section 5.4. So in the last video, I showed you how to solve a differential equation with constant coefficient by using Laplace transform and the inverse Laplace transform. So similar techniques can be used if you are solving a system of ordinary differential equation with constant coefficients. Okay, see that y1 prime is negative 5y1 plus y2 and y2 prime is negative 9y1 plus 5y2 and y1 0 is 1 and y2 0 is 0. So to solve this system, what we do is you take the Laplace transform on both sides. So Laplace transform of y1 prime is s times Laplace transform of y1 minus y1 0 minus the Laplace transform of negative 5 times Laplace transform of y1 plus Laplace transform of y2. Similarly, you took the Laplace transform and then you plug in the initial values there. y1 0 is 1 and y2 0 is 0. So what I did after that is I collected this term and that term on the left side. So I got s plus 5 Laplace transform of y1 taken out minus Laplace transform of y2. Okay, this I brought that Laplace, all the Laplace transform on the left side minus that, and equals to that 1, negative 1 goes to the positive 1 on the right side. Okay, similarly we did for the second equation. Now you can write this in the matrix form, right? Because you see that this is Laplace transform of y1, Laplace transform of y2. Similarly, Laplace transform of y1, Laplace transform of y2. I wrote in this matrix form: s plus 5 minus 1, the coefficient of that, and then 9, right, and then s minus 5. So y1 Laplace transform of y1, Laplace transform of y2. This is the matrix multiplication, right? And in the right hand side you have 1 and 0. So which is in the form of a times Laplace transform of y. So Laplace transform of y is that matrix equals to b. Now you want to solve for Laplace transform, right, first, and then we will take the inverse Laplace transform later. Okay, so what you do, what you get, you multiply both sides by a inverse. If you get Laplace transform of y is equals to a inverse b. But since this is a 2 by 2 matrix, how do you find out the a inverse? What you do is you swap these two, right? You swap these two and then you multiply these by the negative sign, right? Like that. You see that? So what I get is 1 over determinant of a. That's the formula for the inverse of the a matrix A. 1 over determinant of a, and then you swap those two. You got s minus 5 goes here, s plus 5 goes here, and you multiply this. So it will be plus 1. This will be negative 9. You see that? That's what you get. Now this is what you get. Okay, now what we do next is you just multiply these two matrices, right? So s minus 5 times 1 plus 1 times 0 is s minus 5, and you multiply by that. And similarly, negative 9 times 1 is negative 9, divide by that. So the s plus 5 times 0 will be 0. You see that? Now, so what is the Laplace transform of y1? That's the top part, right? And the Laplace transform of y2 is the bottom part. You see that? Now what you do next is you take the inverse Laplace transform. To take the inverse Laplace transform, you need to look at the table given in the page 313. So page 313, that has the table of the inverse Laplace transform formula. Okay, so what it says is the formula number 6 and 7 and 8. Okay, formula number 7 is this one. If there is a Laplace transform of a over s square minus a square, it is sine hyperbolic at. And then if there is a Laplace transform of inverse Laplace transform of s over s square minus a square, if there is plus, it will be cosine, just cosine. If there is plus, that will just sine. If there is minus, it will be cosine hyperbolic and sine hyperbolic. Okay, that's what you will get. So you see that. So to find out the inverse Laplace transform of this, you take the inverse Laplace transform on both sides. You will get y1 equals to s minus 5 over s square minus 4. For this one, what you can do is you can do s over s square minus 16, right? And then minus 5 over s square minus 16. That's what you can do. So for s over s square minus 16, it is 16 is 4 square, right? A square. You see that? So it will be cosine hyperbolic 4t. That's what you get for the first term. For the second term, you need a over s square minus a square, but we don't have a, right? What you do is I write 5 over 4 times 4 over s square minus 4 square. That's what I can write for this one, right? You see that? So that is why negative 5/4 and sine hyperbolic 4t. Similarly, the second one is you have to do negative 9 over 4 times 4, and then s square minus 4 square, right? So that will give you negative 9 over 4 sine hyperbolic 80. So this is basically the final solution for this system of equation. Okay, so I'll take one more example similar to this.